Hello everyone. In this video, we will discuss the 5 major mass extinctions that have occurred on our planet. Over 99% of all organisms that have ever existed on Earth have been wiped out. Older species become extinct as new species evolve to fill ever-changing ecological niches. However, the rate of extinction is not constant. At least twice in the last 500 million years, 75 to more than 90% of all species on Earth vanished in a geological blink of an eye, and what is known as mass extinctions. So let's get started. First, we are going to look at the first mass extinction. The end Ordovician extinction, the 1-2 punch. Around 443 million years ago, ice sheets advanced, dramatically altering ocean currents and resulting in a harsh climate in the equatorial and mid-latitude regions. Many species that survived the initial shock adapted to their new environment, only to perish in the second pulse, a sudden melt, another climate shift, and another ocean circulation shift. Around 86% of species and 57% of genera, the next higher taxonomic division, which may be a more accurate indicator of biodiversity loss, became extinct. Among the animals that did not survive are the majority of trilobite species, numerous corals, and several brachiopods, a type of marine invertebrate with a hard shell that is frequently mistaken for a clam today. Sea sponges fared well following the end Ordovician mass extinction, a pattern repeated in subsequent mass extinctions. According to a 2017 Current Biology study, these insignificant marine animals may aid in the recovery of entire ecosystems. The sponges act as a sediment stabilizer, promoting the growth of brachiopods and other suspension feeders. Next is the end Devonian mass extinction. The long road to oblivion. Between 359 and 380 million years ago, while the term mass extinction implies an instantaneous global disaster, these events can take millions of years to occur. The end Devonian was characterized by a series of climate change pulses over a period of more than 20 million years that resulted in periodic and abrupt declines in biodiversity. Including the Hangenberg crisis, which some researchers regard as a distinct mass extinction event. The changes, which may have been triggered by significant volcanic activity in Siberia, resulted in decreased oxygen levels in the oceans and other environmental changes. Around 75% of species and 35% of genera became extinct. Regrettably, those magnificent armored fish known as placoderms have been wiped out. Numerous coral species and additional trilobites perished as well. The smallest creatures, particularly those less than a meter in length, fared the best, about 3.3 feet. Survivors included tetrapods, four-limbed animals migrating from the sea to land and eventually evolving into reptiles, amphibians, and mammals. The third one is the end Permian mass extinction, or so we call the big one. Volcanic activity in Siberia is believed to be the primary cause of this most powerful mass extinction 251 million years ago. Volcanic eruptions on a regional scale spewed toxic gas and acidified the oceans. The disruption may have harmed the ozone layer, allowing lethal ultraviolet radiation to enter. According to a 2014 study, the apocalypse occurred over approximately 50,000 years. Around 96% of species and 56% of genera became extinct. So many forests were destroyed, apparently by wildfires, that there was nothing left to burn. Researchers have discovered a geological charcoal gap. Numerous amphibians and several synapsids perished, a diverse group of animals that included several apex predators of their day. Numerous fungi fared well during the event, possibly because they fed on all the decaying organisms that did not. The extinction of numerous top-of-the-food-chain synapsids may have paved the way for the earliest dinosaurs, and the first mammals, which descended from one survivor synapsid branch. Then the end Triassic, where history nearly repeats. Volcanoes were at it again 201 million years ago, but this time we can't blame Siberia. Rather than that, massive eruptions in a hot spot in the heart of what would become the Atlantic Ocean triggered another bout of climate catastrophe. Furthermore, it sounded like an echo of the end Permian. Around 80% of species and 47% of genera became extinct. This was not an advantageous period to be a conodont. Already in decline, the last of these ribbon-like fish, as well as a number of reptiles, took the brunt of the attack. After the end Triassic, dinosaurs reached their peak of diversity, as did their archosaur relatives, the crocodilomorphs, descendants of which include modern crocodiles. And the last one is the End Cretaceous, which really made an impact. The End Cretaceous extinction occurred 65.5 million years ago. The cause of the End Cretaceous extinction remains a point of contention. Nobody denies that a space rock collided with the planet near Mexico's Yucatan Peninsula at the time. However, researchers disagree on whether the asteroid strike precipitated or exacerbated the die-off. Large-scale volcanic activity in India's Deccan Traps was already underway prior to the impact, and a study suggests that both the asteroid strike and Deccan Traps activity occurred concurrently with a global increase in volcanism. Whatever the catalyst, it appears as though an increase in carbon dioxide and a decrease in ocean oxygen levels were followed by a rapid cooling following the asteroid. Around 76% of species and 40% of genera became extinct. The sun set on the long day of the dinosaur, but many other organisms perished as well, including ammonites, spiral-shelled mollusks. Mammals, like the sole surviving branch of dinosaurs, better known as birds, quickly adapted to exploit newly vacated ecological niches. The extinction event during the Pleistocene epoch. The extinctions began approximately 12,900 years ago, at the start of the Younger Dryas time interval. Mammoths, mastodons, camels, saber-toothed cats, giant ground sloths, and giant armadillos have all perished as a result of the extinctions. For decades, the role of climate change and humans in these extinctions has been debated. Additionally, there is compelling evidence for climatic change during the extinctions. The Younger Dryas was a roughly 1,000-year period of cooling that came after the end of the last ice age. A new but contentious hypothesis proposes that explosions caused by the fragmentation of a large comet in the Earth's atmosphere 12,900 years ago resulted in the outflow of meltwater from Lake Agassiz and subsequent climate change. Additionally, the explosion sparked forest fires, destroying mammalian habitats. Large animals are particularly prone to extinction due to their characteristics. Because they require more food and habitat than smaller animals, their population sizes. During this mass extinction, some species in the Philippines went extinct. And these are the following. Homo luzonensis. Locally named Ubag in reference after mythical cavemen, with earliest possible attestation of existence during the Middle Pleistocene, which dated 777,000 to 631,000 years ago. The different species of Stegodon. Stegodon trigonocephalus, orientalis, luzonensis, mindenensis. Stegodons were present from 11.6 million years ago, to the late Pleistocene. Nesarhinus philippinensis. The Philippine rhinoceros, it presumably have existed in the Middle Pleistocene about 709,000 to 68,000 years ago. Megalochaelis sundari. Also known as Luzon giant tortoise, lived on the island of Luzon during the early Pleistocene up until 1,700,000 BCE. There are more species in the Philippines during the Pleistocene extinction, but as of now these are the species which fossils are dated.